Hi, I'm Rex Black, President of RVCS. Welcome to the RVCS YouTube channel. Hey, I hope you enjoy all these free resources that are available here. And do us one favor. We need to keep the lights on and we need your help to do that. So, when you need testing and quality related services, training, consulting, expert services, you name it, let us be one of the bidders on that next job. We don't expect to get all of your business, but we'd like to get a chance. Thanks and enjoy the shows.
System response time problem. What does that usually mean? So that's skewing. Skewing can happen. Another thing that can happen is that the distinctions on the scale of likelihood ratings or impact ratings are not well defined or not well internalized. So we want to check to see if that's happened, and it's very easy to do when you've captured these risk items and their ratings in a spreadsheet, because you can create a histogram like this guy here. And basically what we have in this histogram is with the number of risk items associated with each rating. So we have, looks like about 2 risk items that had a risk priority number of 1. And it looks like we've got 6 that had a risk priority number of 15. And we've got 4 that had a risk priority number of 16, and so forth. So we can see here that there's a bunch of risks that have a risk priority number of 6, and that's kind of a problem, because what you really want in this distribution is something. You want something that is normal-ish. Now I say normal-ish because you're never going to get this precisely normal. By normal, I'm referring to a bell curve or normal curve or Gaussian distribution, whatever name you learned for this in college, but it's the bell curve. And you want to have your histogram look more or less normal. Now don't get too bogged down in the details of, oh, it's not perfectly normal, so I got to go tweak some values and tweak some values. No, that's not what I'm saying here. What I'm saying is, if you see gross deviations from a normal distribution, as we see here, then it's probably a good idea to, not probably a good idea, it is a good idea to go through and try to figure out why the clumping is happening. So here we've seen clumping, and specifically a form of skewing. That's the ratings are skewed to the more risky side of the scale, which is a concern. Now, what we do when you see that is that you look at the number of risk items that have particular likelihood ratings and the number of risk items that have particular impact ratings, and you want to try to identify where the skewing comes from and where the problem is. Now, at first, if you look at the left-hand side here, which shows the number of risk items at the particular likelihood counts, that almost looks like there's a problem here. Particularly, you get it down here, and you go, wow, it really does seem to be pretty heavily skewed towards the less risky end of the scale. But this is a mature, well-established product. It's got a maintainable, solid code base, very experienced developers. So this is actually the likelihood distribution that you would expect for a product like this. Where the problem comes in is in the right table. You notice that fully half of the impact ratings are right here at 2, impact of 2, or in other words, high impact. And that's problematic under any case. Now, it's possible that there's something fundamental about the application that tends to skew the impacts towards the higher end of the scale too. But the bigger issue is, if that were the case, you'd expect that you see the kind of distribution that we see over on the likelihood side. But certainly you don't want all 50% of the risk items to have the same impact rating. That's a clumping issue where you have a problem with this distinguishing between the impact ratings, in this case of 2 and 3. So we fixed that. We changed the definitions of what the ratings were for 2 and 3, what that implied from an impact point of view, and you can see these precise definitions and the changes we made in the article, as I said, that's on the website, risk-based testing article. But this is now the adjusted risk priority number histogram based on that reevaluation. And as you can see, this is closer to a normal curve. So it was a pretty simple problem to fix. Just change the definitions, go through and look at some of the 2s and see if they would actually fall into the 3 categories, and reconfirm with the stakeholders that those changes were okay. And that turned out to solve the problem. And here you can see I just had a transition there. You should have caught that showed that changing from the old distribution to the new distribution, where you can really clearly see the distinction between the 2 and why this repaired distribution is better. I'll run that animation here again in case you didn't catch it. You can see that the revised distribution is clearly much more normal. Okay, so now at this point we've got a solid quality risk analysis document, and it's a good basis for testing. So at this point, Test Manager is going off to align the testing with risk. So one of the things that he did was he goes through the risk items, and he goes through the specifications. Specifically, he had a product requirement specification and a detailed design specification. Now, the way you do this is you go through and you review the requirements spec and the design spec, basically any specs that you've got, section by section, and you check to see that there's a corresponding risk item. You should be able to capture traceability of the specification to a risk item. If you've got a specification element that doesn't correspond to a risk item, that's probably a hole in your risk analysis, because there's always a risk that something could go wrong. Now, some sections of the specification, like an introduction or something, may not map to a risk item, but the main body of the specification really should. So if you find any risk items that, or any specification elements that don't have risk items, you want to add a risk item for that. You want to capture traceability between the risk items and the specifications, and that's going to be helpful to you if/when the specifications change, and you can go through and rather than have to review all 100 to 200 risk items and see how the change to the specifications affects the risk items, you just look at the risk items that relate to that particular specification element. Now, it's not necessarily the case that every risk item has to map to a specification element. Every specification element should map to a risk item, or otherwise there's a hole, but sometimes you'll find risk items that don't necessarily map to specifications. Now, you could say, well, that's an issue where the specifications are incomplete, and that might very well be the case. Something you could escalate as a byproduct to project team to see if they want to address that. But you know, that's not unusual, and I wouldn't worry about it too terribly much. Just capture that fact that you've identified a risk that doesn't map to a specification and escalate that to the designers and business analysts and so forth. Now, map the risk items to the test cases. This is something you'll need to do if you do have an existing set of test cases. If you're working on a what's called a greenfield project where everything is brand new, then there won't be any existing test cases to map the risk to. But most of us have existing test cases, and you need to map the risk items to the test cases. And you know, you might very well find that there are risk items that don't have test cases for them, and if they're sufficiently high risk that they need to be tested, then that's potentially a problem. You need to add tests. Now, what you'll want to do is evaluate and reallocate your testing effort overall based on the level of risk, and I'll talk in a minute about how we did that. And then propagate the risk priority numbers of the risk items down into the test cases associated with them, and that's going to allow you to sequence your test cases, and also, again, if you have to triage them, then you'll be able to use that. Okay. Oops, pardon me. Got one slide ahead of myself there. Now, this is the effort allocation table for this particular project that shows the mapping of the risk priority number ranges to the extent of testing. So basically, any risk item that had a risk priority number between 1 and 12 was going to get extensively tested. 13 to 16 gets broad testing, 17 to 20 gets cursory testing, and 21 to 25 gets opportunistic testing. There's another extensive testing that's commonly used, which is report bugs only, which is not on here, which basically would be that if you found you would not do any testing against that risk item, but if you found a bug related to it, you would report it. Now you can see over here in the comments an explanation of the different extensive testing other than the report bugs only. But what I want to do is just try to illustrate these actually with an example that might complement the description that you see on the slide here. Let's suppose that you are testing a word processing application like Microsoft Word, and you've identified a risk in the area of functionality, fails to open supported file. Now, Word can open a lot of different types of files, and there are a lot of object types that can occur in a file. It's not just text, but it can be pictures and tables and headers and footers and different fonts and so on and so forth. So there's a lot of object types and a lot of file types. Now, you say you want to do extensive testing for that risk item. Then you'd be saying that you want to make sure that you test every supported file type, and within every supported file type, every object type supported for that file type. So in other words, combinational types of testing. So that tends to be an expensive proposition, but if you say it's high risk, then that's what you need to do. Now, broad testing, you would say, no, I'm going to run every supported file type, and I'm going to test every supported file type, and I'm going to test every supported object type, but not combinations. I'm just going to make sure that every supported object type occurs at least once in some supported file type. Cursory, you'd say, well, I'm not even going to do that. I'm just going to select the most important file types, the most important object types, and I'm going to test those. And then opportunity, you would say, you know what, I'm not going to create any test specifically to test this, but I'm going to look for opportunities to exercise some file open functionality as part of testing something else. It's going to be a small and incremental investment. And then report bugs only, which I'm not showing here, but if you had that defined, then that would mean that you would not do any testing at all for this file open capability. But if you did see a file open bug in the course of testing something else, you would report it. Okay, so you can see this is the effort allocation table that they've got here, and I'll just point out the risk priority numbers associated with extensive testing. This is a pretty broad range, and you might say, wow, well that's really, they're going to do a lot of testing, and that's true, but this is a data center utility that really pretty much has to work in order for a data center to stay up. There's some pretty significant problems that are associated with this utility not working. So it's this kind of effort allocation is appropriate to the overall business risk associated with that application. Now, we got a finalized risk item, risk priority number, and effort and test case traceability and so forth. So the test manager then prioritized the test cases based on the risk priority number, as I mentioned. And Jim, the test manager, told me that created some fairly significant changes from the older purely requirements-based approach. Before, what had happened a lot was that the tests were assigned to testers based on their experience, like who's the most qualified to run this test. Well, what ended up happening was you had a handful of people who were like the key players, had the most experience, and of course they ended up getting most of the tests assigned to them. Unfortunately, and not just most of the tests, but almost all the important tests. So what that ended up doing was delaying running of important tests, and thus the discovery of important bugs. So really late in the project. So what the insight that Jim got from this risk-based testing was, well, don't do that. You want to sequence the test based on risk, and look for some ways to get more creative about who runs what when. And that then changed the way that the tests were run, and the higher priority tests were run much earlier, lower priority ones later, and that with a consequent effect on bug finding. They also drove risk-based testing into their bug management process, so they started to augment their severity rankings with the risk prioritization of the tests that had identified the bug, which is a creative thing to do. And then, when there are high-risk problems, they focus their bug fix efforts on that. Okay, so at the end of the project, we did a retrospective discussion, and what are the benefits and what are the key lessons learned from this pilot project. And in terms of benefits, they felt that they got an intelligent effort allocation within their constraints, that they did achieve the priority order bug discovery, which and then optimized the bug fix time available for each bug based on its importance. They did experience some schedule compression, or actually it was resource compression. They had a resource get pulled off the test team, which before would have been a real problem, but they had some flexible handling options for that, and that allowed them to triage their tests and be effective and flexible in dealing with that resource constraint. And overall optimization of quality within the constraints due to the focused testing and an ability to talk about quality and quality risk with the key stakeholders, make an informed release decision. Now, some key points, some key lessons learned, things they wanted to do differently the next time. They wanted to include an even broader spectrum of business stakeholders. They felt that getting the impacts rated right was something that they needed even more focus on, and so that was something they wanted to do. In fact, they were even thinking of something that was fairly radical, which was inviting some of their beta test customers, who were real reliable customers, to participate in the process. So, obviously that entails a certain maturity level in the people involved, the customers involved. They can't look at it as an opportunity to beat people up, but it could very well work for them. They also wanted to start the risk analysis earlier in the life cycle. They wanted to start it in parallel with the requirement specification phase, which on a sequential life cycle model is definitely what you want to do. You maximize the benefits if you do that, particularly some of the side benefits of identifying problems in the requirements, but also just having the tests written in risk order ensures that the greatest amount of attention is given to the most important tests. So the overall conclusion at CA was that risk-based testing would allow them to deliver increasingly sophisticated and complex products, which we're all called upon to do. Products get more sophisticated and more complicated over time generally. But we all also called upon to deal with tightening constraints, particularly now, the financial situation, and that risk-based testing helped them deal with the constraints, and allowed them to really prioritize testing and quality and balance that against the other priorities. So they're sold on it. As I said, we've done a number of risk-based testing pilots for CA at other locations around the world, and they're a big promoter of it, and I think a big success story of it just in general. And it's been very successfully deployed there, though of course we have successfully deployed it with a number of other clients as well. So this is not just a technique that only people in the enterprise software development business can do. We have clients that are banks and video game companies and a whole spectrum of capabilities and domains and so forth that are using this. So definitely a robust and useful technique, and I hope that this webinar has given you some ideas on how to apply it yourself. That concludes the presentation, and so at this point, as always, we'll have a 30-minute Q&A period for those of you who want to submit questions. There are questions that can be submitted via the webinar Q&A feature here. So let me get the questions up here and see what we've got. Let's see, we had a couple questions or comments saying that people are having difficulty hearing me. I'm afraid that's really not under my control. Hopefully you can all hear me now, but that can be, something can happen on your end in terms of the voice over IP coming down. So So you can occasionally get some kind of weird chipmunking sounds or so forth. So I hope that hasn't been too much of an issue for everybody. Let's see, got a question from Gayatri. How is risk-based testing applied for performance testing? Well, basically, risk-based testing spans all of the different test types, including performance testing, and you would be able to identify risk items related to performance, and then your tests would be focused on those based on the level of risk, as I mentioned before. So really, it's perfectly usable for that type of testing, but it's also really beyond that because the risk categories include performance, but also go beyond it to look at other things. Now, you could do a risk analysis where you focus just on performance-related risks, and then in that case, it's basically going to determine what you're going to test and how much. But I would really encourage you, unless there's a specific reason why you're just focusing on one risk category, to actually look at the broader range of risk categories. Okay, I got a question from Sarah here. How to apply risk-based testing if we are hand-in-hand with requirements? If we don't have all the requirements defined, how to establish what is more risky or not? Okay, this is a good question, Sarah, and I'm glad that you brought it up. Risk-based testing can use the requirements as an input, as we saw in the case study. But you do not have to have a set of requirements in order to make this work. In fact, we have implemented this for clients where there was not a written requirement specification. In fact, there was no requirement specification at all, and there never was one. And then what happened then is that the experience and shared vision of what the product was to do was present in the stakeholders who are participating in the process, risk-based testing, the risk analysis process. And so that worked perfectly well. Now, I assume that there is going to be some number of risk items that you might not identify in an underspecified situation, but you'd be surprised at how few new risk items are identified when you go through and look at your risk items against the specifications when you go through that part of the process. Usually it's pretty small incremental amount. So I would encourage you to look at risk-based testing as a strategy that can be applied, especially in underspecified situations. So if that's what you're dealing with, then this is a tool to help you deal with that, because it gives you a test basis in a situation where you otherwise wouldn't have one. And now, if you do have requirements, you might be saying, well, why do I need to do this? Because if I've got the requirements, I just use the requirements as a test basis. But notice that the requirements-based testing is a brittle testing strategy in a lot of ways. I mean, if your requirements, where the requirements are wrong, the tests will be wrong. Where there are holes in the requirements, you'll have gaps in your testing. The requirements typically cannot tell you how to allocate test effort or how to sequence your tests unless you happen to get very detailed prioritization of requirements. But what we typically see with a lot of our clients is, yeah, the requirements are prioritized, but everything's a priority one, so that's not particularly useful. The requirements can't tell you how to triage your tests either. So, the addition of risk-based risk analysis and levels of risk and so forth on top of the requirements is very helpful. So basically, if you have the requirements, what you're pursuing is a blended risk-based and requirements-based testing strategy, and we find that works quite well. Let's see, I got a question from C's here. Do you have experience with risk-based testing on a breakdown of functionality? Let's see. Breakdown of functionality. Okay, I assume, C's, what you mean is going by functional areas rather than by risk categories. That is an approach that you sometimes see in certain formalized approaches for risk-based testing when applied to hardware or something like that. If you read Stamatis' book on failure mode and effect analysis, you'll see that that's a technique that he talks about. Now that is not something that I would recommend here. You really do want to look across all of the categories and try to identify risks in all of those areas, because otherwise the non-functional testing gets shortchanged, and that's a classic testing worst practice that we blunder into as testers. And so really would encourage you to use that list of risk categories. Now you can tailor that, and you can add and delete and so forth, and that's by all means your prerogative to do. But I would say don't just exclude categories of quality risks other than functionality. It's like, oh, well, we don't have to worry about that, because really we should. Okay, so question came up in an earlier session of this that I want to address, which is how risk-based testing works with the different life cycle models, where it fits in. So if you're following a sequential approach, like was the case of the case study that we looked at, the pilot, what you're going to do is you're going to try to do your risk analysis in parallel with the requirement specification, using a draft of the requirement specification as an input into that process. And then periodically at major milestones, such as approval of the requirement specification and the finalization of the design specification and completion of implementation and unit testing, and then after the first, say 25% of test execution, these periodic intervals, you're going to look at the new information that you've got and then adjust your risk analysis, add new risk items, adjust likelihood and impact for existing risk items, reprioritize your tests and so forth. Usually what you find, if change is reasonably well managed on the project, that those are fairly incremental changes that you're making. Now, in an iterative life cycle, instead of doing one big risk analysis all at the front, what you do is you do a iteration-specific risk analysis, which of course is going to be smaller for each one of the iterations, and so it's focused, and the effort is less than well, for each iteration the effort is less than the effort required to do a bigger risk analysis. Now, when you get into the Agile world, then what you're typically going to do in the Agile approach is you have a separate risk analysis at the beginning of each sprint or iteration for the Agile approach, and that's going to be very lightweight. It's focused just on risks associated with the user stories that are being created for that particular sprint, and any other non-functional areas that you need to look at. So then it becomes a very, very lightweight kind of thing. Now, let's see. Sarah's got a follow-on question here of, can we use this approach with exploratory testing? Use the stakeholder's vision to determine what to explore most. Well, Sarah, I do want to see a blended approach that includes some amount of reactive testing, such as exploratory testing, in conjunction with risk analysis. But I would actually encourage you to not guide the exploratory testing by the risk analysis, but rather to let the testers use their own experience and judgment and intuition guide their exploratory testing. And here's why. One of the risks, if I may use that word, of any analytical testing strategy, and risk-based testing is clearly an analytical testing strategy, is that the analysis can be wrong. In fact, any analysis, to some extent, is wrong. The question is, to what extent is it wrong, and how big of a deal is that? So in the case of risk analysis, what's going to be wrong is you're probably going to be missing some risk items, and you're going to have some risk items that are rated in terms of likelihood and impact. Now, you need to have something built into your process that allows you to counterbalance this, to counteract this. And this is where the reactive or exploratory testing comes in. So what you're going to do is, by freeing up the testers to look in areas outside of where you've created the scripted tests using the risk analysis. And when I say scripted here, I just mean written. I don't necessarily mean any level of detail. But we free the testers to use exploratory testing in areas that might go beyond where our analysis told us to test. And then what we do is we look and see across all of our test results, including our exploratory testing, are we finding a lot of bugs where we said that the likelihood was going to be low? Or conversely, are we finding very few bugs where we said the likelihood was going to be high? Are we finding high impact bugs where we said that the impact was going to be low? Or conversely, are we finding low impact bugs where we said the impact was going to be high? Are we finding bugs in areas that we just had no inkling about? We have no identified risks for those. Now, so if any of those 5 things is true, and to some extent they will be true, that those indicate some sort of problem with your risk analysis. But see, it's difficult to find those kinds of things, especially the 5th one, the bugs in areas where we have no identified risk items, without freeing up the testers to say, look, when you're doing your exploratory testing, just look wherever you think you ought to look. Don't be constrained to the particular risks that were identified in the risk analysis. So I would say, definitely use exploratory testing as part of the your strategy, but set the testers free to go beyond the risks that were identified, and you'll get a much better result out of that. Okay, I got a question here from Jason saying, could you specify the quality risk category link? Jason, for the purposes of avoiding a long period of silence as I search around for it on my website, I'm not going to go do that right now. But what I can tell you is, if you go out to, if you're on the RBCS website right now, there's a option of resources, and that generic quality risks list is either on the basic library page or it's on the advanced library page that's accessible underneath that resources selection on the RBCS website. So you can definitely find it there. It might take you a while to dig around because there's a lot of stuff there, but it is on one of those 2 pages. So the link is definitely to one of those 2 pages, and then you'll just have to look around for that list once you get to that page. Excuse me. Okay, so I'm not seeing any additional questions at this point. Okay, here we have one more coming in from C's. That's a good one. Have you encountered any disadvantages to risk-based testing? Okay, that's a good question, C's. I used to have some disadvantages with it when I followed a more formal approach. When I first got started doing risk-based testing, what I used was a technique called failure mode and effect analysis, which is very, very formalized. And the disadvantage there was that it's just a tremendous amount of work to do those spreadsheets that you have to do failure mode and effect analysis. And it's easily like 10 times as much verbiage as the lightweight technique that I just showed you. So over the years, I developed this lightweight technique that I call pragmatic risk analysis and management, and that really is, it provides all of the benefits without the tremendous overhead costs of the more formal techniques. So that's one way to help manage the disadvantages, is to use a technique at the appropriate level of formality, and you don't waste a lot of effort on things that aren't giving you a lot of incremental benefit. Now, are there specific cases where I can imagine not using risk-based testing? Yeah, absolutely. I mean, I think if I'm like our Sri Lankan operation, Software Test Works, we do outsource testing, right? And in some cases, the client is going to say, look, what we want you to do is test these things. They're going to tell us exactly what to test. That's called a directed testing strategy, by the way. You're following a directed testing strategy when you're counting on someone else to tell you what to test. And that happens in outsourced testing not infrequently. So in that case, there would be absolutely no point in doing risk-based testing because you know there's no latitude for discretion about what to test and how much. I mean, they've told you what they want you to test and how much. Now, you might ask them, why don't you enlighten me a little bit about the order in which you want me to test things? They might have done a risk analysis. But you know, that's one circumstance. And I guess the other circumstance that would potentially make this harder to do would be if you have no preparation time. But I do want to point out that on the case study that we looked at, the risk analysis was done concurrent with the start of test execution, and they still felt that they got a lot of benefits out of it. So I would say even in the case where the test execution is starting, or excuse me, the risk analysis is starting late and almost in parallel with the start of test execution, that still doesn't preclude getting the benefits out of it. You know, as I said at the outset, the costs associated with doing this are really pretty low. Particularly in the context of the kind of benefits that you tend to get. Okay, well, to close, wait, one more question from Cease here before we close. Can you address the reprioritization of risk? Yes, certainly. Basically what I'm talking about there, Cease, is when you go through and you look at the new information that you've gotten, whether that be test results or design specification or what have you. What you want to do is say, okay, is there anything here that tells me that my risk analysis is missing a risk item, or that the likelihood or impacts need to be adjusted? And then so you would then make those adjustments. And then what's important is that those adjustments ripple through into your testing. So through the traceability of your risks to the test cases, you push the new risk priority numbers down into the test cases that you've created. Now you also want to, of course, that's going to cause you to reevaluate prioritization and sequencing of the tests and so forth, and possibly triage. You also want to look at the issues of effort allocation, because it might be that by reprioritization of the risks, you discover that you need to add some tests in a particular area, in which case fine, or that there are some of the tests that you created already for a particular area, or maybe you haven't created them yet, but you're going to create them, that you don't need because the risk isn't sufficiently high. Now, obviously, that's some amount of inefficiency there if you're dropping tests that you don't necessarily need, but of course you don't delete them. You just say, I'm not going to run these. I'm going to skip these because the risk isn't there to justify running them. You don't want to just go ahead and continue to run tests that have a lower level of risk. Like, oh, well, just because I got them, I'm going to run them, because, you know, again, a lot of what risk-based testing is about is focusing your test execution effort. And if you run tests that aren't particularly high risk because you already wrote them, then that's really not going to make a lot of sense. Now, I see you have a follow-on question here, C's, which is, I think, a good one. So I'll get to is a logical grouping of high priority risks with lower level risks, can't there? And okay, so one of the things that you could be talking about here is efficiency of sequencing of tests, and if that's what you're getting at, well, yes, absolutely. There can be constraints and efficiencies associated with running particular tests together in a group. That kind of argues against running the tests in pure risk order, and then that's definitely something you can do. Just remember that the extent to which you're responding to those constraints and in changing the order in which you're running the test, you will undermine the benefit of risk-based testing that has to do with discovering the bugs in order of importance. So you want to be really careful about the degree to which you do that. And if you find that, the tests are all written and they need to be run in a particular order, which is not the order of risk, usually what's happened at that point is that you've introduced unnecessary and unfortunate dependencies between test cases that really should be engineered out, because certainly it can be the case that it can make more sense to run some tests in a particular order, but if you find that the test can only be run in a particular order, many times that's bad test design and engineering that should be looked at. Now, another thing that you might have been getting at here with your question, C's, and maybe you're getting at both, is if I run the tests in pure risk order, isn't there a possibility that I might never get to certain things? And wouldn't it perhaps make sense to have some number of lower level test cases, lower risk test cases, run earlier in the test execution effort, just to make sure that I've got breadth of coverage across the different functional areas and non-functional areas? And the answer to that is yes, absolutely. I mean, there's in my book, Advanced Test Management, or Advanced Software Testing, a book on test management, so it's volume 2. I talk about this approach to breadth-based risk-based testing, or breadth-first risk-based testing, where you want to make sure that you are sampling across the different functional areas and the non-functional areas in the first, say, third or even quarter of the test execution period. Now, you're still focusing on the higher risk stuff, but you're including some amount of lower risk stuff in your tests just to make sure that you don't miss them. Because if you do think that you're going to get squeezed on your testing, then that's certainly something that could become a problem if you get so squeezed that you end up not testing entire areas. Then the residual level of risk could be pretty bad indeed. Okay, so to close this session, I want to tell you a little bit more about the resources available through RBCS. And as I think many of you know, we run these free webinar sessions once a month. So check our website, rbcs-us.com, to sign up. If you want a special webinar presentation for your company only, this webinar or any other topic related to software testing, please contact us at info@rbcs-us.com or via our website. If you don't already receive our regular free newsletter, sign up at rbcs-us.com. By signing up, you'll get valuable discounts on consulting and training services, along with a regular newsletter that includes a featured article on software testing and quality and news about what RBCS and its partners are doing lately. You can also follow us on Twitter at twitter.com/RBCS and on Facebook at facebook.com/pages/RBCS-INC. Finally, check out the digital library, which has recordings of these webinars, podcasts, and videos. And don't forget, there is a extended video of me giving a presentation on this material and more in Melbourne, Australia. So if you felt this was good material and there was stuff that people could benefit from it and you'd like to hear more, maybe set up a session where you and some of your colleagues could view that video, because that's certainly not necessarily everything there is to know about risk-based testing, but it's a lot that you would probably want to know about risk-based testing, and it is completely free, like everything that's on the basic library, the advanced library, and the digital library. You can also subscribe to our podcasts via iTunes by entering RBCS Podcast into the search string, and you can subscribe to our videos on YouTube. So go out and do a search for RBCS software testing on YouTube, and you should find us. Okay, well, I'd like to thank everybody for coming, and thank those of you who asked questions for your insightful questions. I always enjoy those questions. I hope all of you will be back for the next webinar, and come ready to ask questions at that webinar as well. So this concludes today's webinar. Again, thanks everybody for joining us, and hope that you have a pleasant rest of the week.